Barry, I'm going to make you host.
Yeah, I hear you now.
Okay, you are now host. So my recording is going to stop probably. Actually, it's still going, surprisingly. Why is it still going?
Maybe they changed the code. Let's just see.
Anyway, Barry, you're now in charge, and now have to go drop off my dogs at the canine resort and head on up to Canada. I'll probably dial in from the road, but it's going to be noisy and I'm going to be hungry. And so don't count on me for being a solid participant today.
All right, so you're going to be on the highway driving to Canada.
Yes.
All righty.
Yes.
You're going to cross on the land side, not the ferry, right?
Right. So there's two places. I think there's a place called White Rock, and then there's the like I-5. There's two standard entry points. And I think White Rock or Blaine is always less crowded. So I'll try that one.
Okay.
Anyway, again, a lot of things seem to be going on. I know last Saturday we didn't get hardly anybody. So I apologize if there's no one showing up. But like I said, this is an opportunity to go to Canada and do some stuff there. And
Yeah.
I've been there in like 4 years.
Okay.
4 or 5 years.
Well, if I just admitted somebody, but I didn't actually pay attention to who it was. So it's Joshua. I'll try to admit him again.
Okay. Anyway, I'm gonna go on to the canine resort. All right. Glad you guys have a conversation all ready to go.
Okay. Good trip then.
Thanks. I'll check in if I can when I can. Okay.
All righty.
All right. Bye-bye. By the way, since you're host, and if there's anything happening to the recording, you can always start another one in the cloud. Okay, just FYI.
Right. Yeah. As long as I stay connected to Zoom, we're good.
Yep. Hey, Josh, I'm on my way to Canada. I'm checking out.
All right, be safe, Sam.
Thanks.
How's it
How are
going,
you?
Barry?
How are you, Joshua?
I'm a little cold this morning, but
I was gonna say, you look all bundled up.
oh, it's freezing out here. I'm just yeah, I'm okay. I got up early and I was just talking with my nerd friends on Clubhouse.
Yeah, I saw your notification to that effect when I turned on my machine this morning.
What did it say?
It just said you were in Clubhouse with, and then it gave the name of a person whose name I didn't recognize. And by the time I clicked on it, I think your conversation must have ended because it didn't show it as an available conversation when I clicked on it.
Oh, interesting.
Yeah. The thing is that it came up, the notification came up on this old Android. And I had left this unplugged, so it was recharging overnight. And so when I checked to see if it was if it had recharged correctly, I saw the notification and I clicked on it, and Clubhouse opened and said two things. It said, first of all, there's a new version of Clubhouse app, and it went to the Google Play Store. Google Play Store says this version doesn't install on your old Android. So then I stuck.
Oh, wow.
So then I stuck with the old version, and it showed some sessions in progress, but yours wasn't among them.
Okay, that's interesting. Yeah, I never know that they're kind of they're really good at telling people what everyone's doing and then not letting you in. Like it's a weird app.
All I know
It's
is
got
I got an alert that you were in this one person private conversation. And then when I launched the app and skipped the non-working update, then it didn't appear at the scroll down list.
Yeah, they made it so if you don't know the people, and there's different ways to open a Clubhouse room.
Mm-hmm.
So there's ones called social rooms, and then there's ones open to the public.
Yeah.
So if it's a social room, only people that know people can go in.
Well, yeah, but I think I've identified Jimmy Gumdrops as a contact. At least, I mean, I think I did.
No, it's not me. If I didn't start the room, if someone else did,
then
it's their permission parameters. Yeah, I
Oh,
was a guest in
you
someone
were a
else's room.
guest. Okay, so then the person who started it doesn't know me. But I got the notification
Yeah,
because
I
you were
never. They lie. They're just trying to get engagement. They're just trying to like,
there. Yeah,
oh look, someone that's in your contacts is doing something on Clubhouse. Come join, and then you go there and there's nobody there.
right.
That happens all the time.
Yeah. So anyhow, I just
Yeah.
wanted to make sure that this was still working after the battery ran down.
Okay.
You know what I use this for? I have one of those gizmos that you can turn on and off a power outlet.
Oh wait, excuse me. I'm getting a call from QCell. Hold on.
And he's back. I'm not hearing you. I don't think your audio is your audio is still connecting. And now you have to unmute. Unmute.
Sorry about that, Barry. My neighbor was coming by, so QCell said, "Come and say hi to George."
Okay.
So I waved hi and came back out.
So you went indoors because it looks you're in a different location and not as
No,
well lit.
I'm just moving around. I'm on a back porch. So this is the door,
Yeah.
and then here's the
Oh, look at
freezing.
that. Yeah.
Yeah, the sun's just about coming up.
Well.
So yeah. So
Yeah,
on the
now you're
other side of the
well lit.
house.
Yeah, now you're well lit again.
Yeah, if I face the sun like this, well, that's too much light.
Yeah, you get washed out.
Yeah.
Yeah. I have the problem that
It's
the sun is coming in at an angle from this window over here and hitting this back wall. So I get a bright sunlight spot on the back wall behind me. And I could pull the shades, but I'm not going to bother because there's all kinds of stuff in the way.
Yeah, I'm gonna put you down so my hands don't freeze. Here, let's check the temperature. Let me see. Okay, Google, turn the volume to 7. Okay, Google, what's the temperature outside? Okay, 36 is where we're at.
Yeah, 36 is what it says here for my outdoor temperature too.
Oh, look, we got the same. We're finally equalized.
Yeah, yeah.
Nice.
I turned on, for just no particular reason, I turned on IPv6 via Hurricane Electric Tunnel, just for no other than just to have it turned on. And while Google News still knows that I'm in suburban Boston, the little weather sidebar on Google News now thinks I'm in Kansas.
What's your
because evidently when I go to Google News, it uses the IPv6 address to go there. And Google says IPv6 Hurricane Electric New York. I guess I'll give them the weather in central Kansas.
Where does it think your IP address is? Is it a server that you're connected to, or?
Well, so do you know about IPv6 tunnels?
No, I don't.
Oh, okay. If this is boring, just tell me and I won't bother. But if you're in it, if you have an IPv4 native address from your provider, and you want to have access to the IPv6 network directly from the computers in your house, you can set up an IPv4 to IPv6 tunnel. And there's a free service provided by a company called Hurricane Electric. And so what you do is you create an account on Hurricane Electric, a free account, and you can get free DNS and free IPv6 tunneling, both of which I use. So I go through the rigmarole, and it's hackish. It's not plug and play. And you tell Hurricane Electric, I would like to have an IPv6 tunnel from my IPv4 address through one of your servers, and I choose the closest one, which happens to be New York. And so after I go through the rigmarole, then I get an IPv6. One of my machines in the house becomes an IPv6 router via this tunnel. And then all the other machines then use that as the IPv6 access router. And
is it a
turns
virtual
out-
router or is it a physical router?
it's actually, I'm actually using a NetBSD machine. I have an old Spark that runs NetBSD, and I let that be the one that negotiates the tunnel,
Okay.
because that machine is just sits in the basement, it's always on. So then that machine says, okay, I'm the IPv6 router through this Hurricane Electric 4 to 6 tunnel, and then all the other machines will say, oh, you have an IPv6 router, therefore I can have a public IPv6 address. So all my machines that use it are now visible, directly visible over IPv6. So for example, this Mac that I'm on, which is normally behind my IPv4 firewall, now is exposed on the IPv6 network. If you happen to know the IPv6 address of this Macintosh, you can actually connect to it directly from outside.
Okay, I gotcha. So, but because it's public and someone else can
Right.
connect, or
So,
is it?
so if I'm outside of my house on a machine that has IPv6 connectivity, that is can reach IPv6 addresses, I can reach this machine directly from the outside world.
So you can just virtually, yeah. I haven't done that in a long time. I
There's
used to.
There's no particular
I mean-
reason to do it. It's just a
There is if you want
hackish.
to access. It's a hackish thing, but I mean, if you do want to be in your house but not in your house,
Right.
I mean, if you want to be on your system and not on your system,
Right.
if that makes sense. Like we used to do stuff like that to share back in the day, to share files on,
Right.
Now it's easy. Everything's easy, but we used to put little desktop folders where people could just drop things in there because we would tunnel
Right.
into the computer.
Right. So
Yeah.
so if I were outside the house on a laptop or any computer that has IPv6 access, then I could do remote screen sharing or remote server or telnet login, or SSH. I
Right.
could do any of that stuff without having to log into some public machine in the house, and then from that, hop over to another machine. But the thing is, I'm never out of the house anyway, so I don't
Hey,
really
at least you
need
know
it.
how to do it.
But yeah, it's the kind of thing that for no good reason you want to know how to, you want to actually play with it and learn how it works. And so, but the downside is Google News now, when I connect to certain sites, it will prefer the IPv6 address as opposed to the IPv4 address to go to a server. And so when I go to
Right.
Google News, it uses the IPv6 address to get there. And then Google News goes, where is this guy? He's coming in from an IPv6 address that is owned by Hurricane Electric in New York City. What should I tell him his local weather is?
And why is it picking Kansas? That's the question.
Well, because it's exactly in the center of the United States. So it's by default. By default, it picks the center of the country.
Oh, that's right, by default.
So I think if I chose a different server, we'll say one in Europe for IPv6,
Mhm.
it would probably think I was in Europe.
Or
And here's,
probably pick London or something, like the default for Europe.
yeah, I mean, if you go to Hurricane Electric and you say, I want to set up a tunnel, what server? It gives you this long list of North American and worldwide IPv6 tunnel servers. And unfortunately, there's not one in Boston. The closest one is in New York. But
So is that the service that these companies, I always wondered how you open up, there's so many VPN companies and they're making like a bunch of money charging people for VPNs. And I'm wondering like, how much are they paying in order to provide the VPN service to people? because I got taken one time by one of those companies. Like, I didn't understand how they billed on the iPhone, and after the trial went up, it just billed me for the whole year by mistake, and I paid $127 for VPN I never used.
Yeah, that's really bad. There's
It
so
is
many,
bad.
there's so many scam. I mean, I tell you, a $3.60 glitch yesterday just got me angry. I grocery shop at Stop and Shop, and they give you these reward points for buying groceries, and then you could redeem them for either a discount on your next bill or for buying gas.
Huh?
So I had accumulated 300 points, which is worth about $3. So I needed a tank of gas. So I put in my Stop and Shop redemption to give me 30 cents a gallon off. And the pump glitched
Oh no.
and ate my 30 cents off, which would be $3.60 for 12 gallons of gas. And then it charged me the full price anyway. And I went to see the cashier, and the cashier basically blew me off and says, "Have a nice day." And I said, "I'm not having a nice day." But it was not a lot of money. It was only $3.60. But the thing is, you go to all this, trouble to redeem.
Right, it's the principle.
Exactly. The fact that the first thing is that it glitched on my credit card. It printed out a blank receipt, so I had to go in and get a receipt with actual ink on it so I could read it. and then it blew away my so it had three things went haywire, and I just, it wasn't just the one thing, but it was the whole, and the guy was just rude.
You just reminded me, I watched a docuseries last night called Where's My Jet? And it's the story of a kid back in the 90s who got Pepsi points because he watched a commercial, and it was obviously a joke, but do you know the story? The kid, he, on the commercial, it says if you get 5 Pepsi points, you get a t-shirt. If you get 125, you get a leather jacket, like,
Yeah.
Pepsi points, whatever.
Yeah, I haven't seen that particular one, but yeah, a lot of companies have these point redemption features.
Yeah, so there was what happened was at the very end of the commercial, the little kid is flying a Harrier jet, and it says 7 million points, you get a Harrier jet. And so this one kid goes, wait a second, let me do the math on this. That's $4 million in Pepsi. A Harrier jet is $30 million. Let me go to my friend who has a lot of money and see if he'll bankroll this and get us a Harrier jet. It's a great story, and
Yeah,
they
it's
actually did all the math on it. The guy said, he's got some money, so he's like, hey, write up a business plan. Let's see if we can make this work. So long story short, he says it's not possible. Like, you can't, he looked at the storage for 4 million Pepsi cans, yada, yada, yada. He's about to give up, and he reads the fine print, and it says redeemable 10 cents per point. If you don't have enough points, like you've got 100 points, you need 125 for your jacket, you can pay 10 cents and they'll give you the jacket. So he found a loophole that it turned out to be $700,000 to get the Harrier jet.
So it was a glitch.
It's a glitch in the system, but Pepsi's like, no one's going to fork out $700,000. So the guy wrote a check for 700,000, sent it to Pepsi, and they were like, "Whoa, wait a second, we can't." It turned into such a legal battle. I'll spare you the whole saga, but
this is a real thing, not a.
It's a real thing. It's in the law books now.
Oh wow.
Yeah, it was really interesting, and the guy who ended up taking the case, a young lawyer named Michael Avenatti.
Oh yeah, he got in big trouble with after the Trump thing. That's
the neat thing about the guy. Michael Avenatti is such a sleazy guy.
Yeah,
he wanted to blackmail Pepsi. He had this whole plan to blackmail them, and the guy who put up the 700,000, he said, you know what, I don't like blackmail, I don't like sleazy business. He had ethics, so he didn't go through with the blackmail campaign. And it was smart because he's like, look at Michael Avenatti now, he's in jail and I'm not.
Yeah, I remember, because he handled that not a stripper, but a call girl for Trump.
Yeah.
can't remember her name now, but yeah, he handled her story.
Stormy Dan. I only know
That's
because
it.
I
Yeah,
watched
Stormy
the
Daniels. Yeah,
documentary.
he handled the Stormy Daniels case, and then somehow or other he ran afoul of the ethic, the Bar Association ethics somewhere after that, and got disbarred or something.
Yeah, I thought it was a fascinating case on ethics because the advertising company that put out the ad, they forgot to put the disclaimer at the bottom. That's just a joke. But they did put the disclaimer on the Canadian ad, the same ad that ran in Canada, which is why they thought they had a case. Like, why would you, if it's really just a joke, why would you put the disclaimer? But it did go to court, and the trial lawyer, the judge was really on the side of big corporations, so she ruled against them.
Oh,
it's like clearly a joke.
Yeah.
But the interesting thing was when they went to the advertising company, because they're the ones liable, the ones that put out the ad, they had 700 million, not 7 million, but it was the font was too tiny to read, so they turned it to 70 million, and they went, the font's still too tiny to read, let's just put 7 million.
Oh,
So they screwed up with the fonts. Otherwise, it wouldn't have been, if it was, 700 million.
would have been, yeah, you would have bought it for real money. Yeah.
Yeah, so they messed up with the fonts. It was a
Something
font
happened
problem.
here in Boston, not a scam like that, but the Boston Symphony Orchestra is the conductor is Benjamin Zander, and he owned a really nice BMW that got stolen, and he eventually got the car back. But in the trunk of the car was a collection of his handwritten notes for conducting one of the Beethoven symphonies. And when you conduct something, you write up lots and lots and lots of notes on the score, because you have to adapt it for your modern orchestra. And that was not in the car when he got it back. And that was an enormous amount of work that he had done, all this, annotation of the score so he could conduct this particular Beethoven piece. And he had to start all over again and rewrite all of his annotations. He said he would rather have gotten that back than the car.
Oh, wow.
Yeah.
Did anyone ever come forward and make a symphony that was his annotations?
Well, so far, I heard the story yesterday. So as of yesterday's version of the story, he didn't get the folio with the scores back. But it's conceivable that whoever stole the car and then somehow got recovered, maybe they'll somehow get that person to return the annotated musical scores.
So interesting what we value. That's
There was a similar story. Nina Totenberg's father played the violin, and he had accidentally left his violin in a taxi one time, and it took decades to get it back, but they eventually got the violin back. I think after the person who absconded with it from the taxi died, and then their heirs found it and returned it. But it was like decades that Nina Totenberg's father's, Roman Totenberg, he got his very expensive, who's that famous violin maker? Italian, not the Guarneri, but the other one. There's two real, was it?
I don't know. I'm just
There's two or three very famous violin makers. There's not very many of his violins in existence, and that was one of those real expensive Italian-made historical violins.
Yeah, I started hanging out with instrument makers for a little bit because I was doing a lot of music, and I ended up meeting all these people that made Japanese wood carved musical instruments, and they had these workshops in the back of their house that they just spent 20 years carving these in. Like, people love that stuff. Like, it's
back
real
in
skill.
the day, back in the day, very fancy wood carvings and furniture carvings and everything. That was the deal. Now what people want is technology instead of fancy china and fancy furniture.
I've noticed a comeback on YouTube. At least there's a bunch of wood carving people that are making, 6-figure living, just making tables for people out of wood.
Yeah, I
That
mean,
they're using.
there's still a niche
Yeah.
market. Still,
Yeah, but it's pretty fun to watch because they're using the new technologies, but old methods with new methods and making really beautiful stuff.
yeah, yeah. So I think, I mean, people still want, beautiful looking Maseratis and all, but damn it, you want a vehicle that actually runs, gets you from A to B. It's an automobile, and then the fancy Art Deco stuff is sort of icing on the cake, but that's not going to make it be an automobile.
Yeah, I never understood. I hung out one time with Al Gore's daughter, and she was explaining to me how her lifestyle works. And I was just like, it's so disgusting. Like the rich people, the way that they conduct their lives. And she was, getting a little tipsy at a party, and she was like, we could auction you off. And I'm like, I'm a human being. You can't, it sounded like slavery. She's like, oh, we could auction you off at one of these fancy rich people auctions, and I bet you'd fetch $50,000. I'm like, that's not how you talk to people. Like, you're a horrible person.
I don't know. It's real. Yeah, people's values are really strange.
Mm-hmm.
Really strange.
Like the more I hang out with rich people in Santa Barbara, like Montecito and those kind of people, I realize that they're just so bored. They have everything. They have the mansion, they have the country club, they have the connections, they have the money flow is not a problem for them because it's old money.
Yeah.
And they're just really like kind of bored. Like they want something to talk about.
I was listening to somebody try to explain what the hell is going on with Elon Musk. And one of the people that was interviewed by the journalist was a funder who had helped Elon Musk come up with the money to buy Twitter. And this guy was a big fan of Elon Musk and sort of kind of knew his ins and outs. And the journalist says, what do you think motivates Elon Musk to do, take on this risky adventure? And he says, Elon Musk is the kind of guy who's not happy unless he is trying to do something that's next to impossible.
Yep.
The stuff that he's done, he's bored with. He always wants a challenge that's a seemingly over the top difficult. And he says that's why he bought Twitter, because it was considered by a lot of people to be an impossible deal. And that's the only thing that gets Elon Musk out of bed in the morning, is trying to do the impossible.
I've watched pretty much every interview publicly he's ever done, like pretty much every one, just because I was bored up in the mountains on YouTube. So I just went back through the archives, and from what I can glean from who he is, he has one of his favorite sayings he says in a lot of interviews is, being an entrepreneur is like eating glass and staring into the abyss.
Exactly. Yeah.
He's comfortable in that state. That's when he's most happy.
The famous, I think it's the Icarus myth, if I remember the right name. Icarus is the guy who wanted to fly high in the sky.
I remember.
So he put on the wings and he flew high in the sky, and the wax melted and he fell. This is sort of the Icarus complex. You fly so high that you get out of your functional zone. And so the Icarus myth is sort of I think the thing that characterizes both Trump and Musk. They get out of their wheelhouse so far that they get to the point where the model is irrelevant. The model is basically you're running outside of the domain in which the model is relevant, and your wings melt and everything collapses on you. And I think there are people like that. I mean, that's where these myths come from. People who attempt to do the impossible, and it is impossible, and they fail spectacularly.
Yeah, I used to be that person. Like I really loved it. Doing the impossible was really fun for me. And then after some failures, I just realized, you know what? Go the opposite route and do the barest minimum, like very Taoist Zen. Like do the tiniest amount so that you appreciate the small little gains, and you don't need that giant gain.
Well, that's like,
and I found that to be more happy.
That's like solving
Yes.
recreational puzzles. So you solve recreational puzzles, and if you fail to solve one, it's no big deal. I mean, you may feel bad
Right.
about yourself, but you haven't destroyed the world. And so most of the things that I do, which are challenging, are experimental, but they're not life and death. That if I succeed, it's wonderful. If I fail, all right, so I failed, big deal. It doesn't, my life isn't over. You know, it's just that experiment failed, and it's not a total loss. But there are people who cannot take a risk unless it's for real.
Hmm. Well, they're gamblers.
Yeah, the gamblers will not get excited about an exercise that's just for fun, just a game. If you play a game
Right.
and your character dies in the game, big deal. You start the game over, or you don't play that game anymore. But people will do it where it's not a game, where it's, you know, they'll bring down the whole country, or they'll bring down the whole company, or they'll bring down their whole, personal wealth or their health.
Yeah. One of the weirdest like human experiences I saw, I used to hold these non-Jewish Hanukkah parties.
Mhm.
So I grew up with Jews. I grew up, with Orthodox. My grandparents were Orthodox Jews, and we would celebrate the holidays, usually the high holidays. We didn't really get to celebrate Hanukkah. But when I got older, my Jewish friends were like, "Hey, what are you doing for Hanukkah?" And I was like, "Let me introduce Hanukkah to my non-Jewish friends."
Right.
So I had my Jewish friend come over, say the prayers, light the menorah, and then I gave them all gold, little chocolate coins, and I just
Gelt.
made some Jewish food. Yeah, I gave them the guilt,
Chocolate gelt.
and yeah, and then we had alcohol, and the next thing you know, I looked over and they were gambling real money with the dreidel.
Oh, the dreidel.
And I saw people pulling out their pockets like, "Okay, I got a bus pass. I'll trade you a bus." Like it would turn into like, I couldn't believe it. I looked over, I was like, "These guys are really getting serious." Like it's something in the human psyche.
Hanukkah is really only a minor holiday, but it was made into a major holiday because it happened to coincide with Christmas.
Right.
So a lot of secular Jews sort of amped it up so they could do something for their children that was parallel to the Christmas season. But it never was a very significant holiday in the Jewish calendar.
Which is why I thought it was okay to just let non-Jews come in and have fun with it. That's why I didn't think I was violating any spiritual law or.
No, it's not. I mean, it's basically stretching a resource to make it last longer than normal. And, you go into your refrigerator and you're getting low on something like milk or butter or whatever, and you stretch it. You use much less of it than you would normally use, and it lasts until the next time you go to the grocery store.
That's why that old story of Jesus turning water into wine, I think that got misconstrued. I think he just poured some water into wine and stretched out the wine. Yeah. And then it turned into water into wine. It was already wine. He just probably added some water so more people could have some because he was a nice person.
Yeah. In fact, I had a chemistry set in which you would do an experiment with phenolphthalein solution, which is the color indicator for acid and base. And so you would take something that was alkaline, which was clear, and you'd put in something to make it acidic. It's still clear. Then you put in a little drop of phenolphthalein solution, and it would turn red. And the name of the experiment was
I'm
turning
saying
water
hi to
into
Dig
wine.
VJ. I'm just saying hi to Dig VJ. Welcome. It's just me and
okay.
Barry
How are
talking.
you? How are you guys? I miss you guys a lot. So
Hey, I missed you
I've
too.
I moved into a new place actually. So I was just trying to settle down. So I finally settled down here. So yeah. Hi, how's everyone?
We're doing okay.
Sam had to go to Canada, so it's just me and Barry chit-chatting about the Jewish holidays and random stuff.
And the Canadian weather came to Joshua.
Yeah.
And here too, we both have 36 degrees. See, we'll have to say that in Celsius for Diggy, I think, don't we?
Yeah.
Well, that's just barely above freezing. It's about 3 or 4 Celsius above freezing.
Wow.
Yeah, I'm at about 1 or 2 Celsius.
Yeah. So we're essentially just a notch above the freezing point in Boston and in California this morning.
I'm sure it's warm. Are you still near Chandigarh?
Yeah, I think it's 15 degrees, and during the peak winters, it goes down to 1 or 2 degrees.
You're
Oh,
still
wow.
north of the equator, aren't you?
No, it's actually quite higher than Tropic of Cancer. It's pretty high from Tropic of Cancer as well. Yeah,
He's in the north of India.
You're
Yeah, it's
so you're
north of
north of the,
India.
you're north of the equator. Okay.
yeah. We were pretty far from tropics. We're pretty
He's
far
close
from
to
that.
the Himalayan mountains.
Yeah. I'm
Okay.
pretty close to that.
Okay. So that means you have winter and summer seasons.
Yeah, both
The
extremes.
same as us, in other words. Yeah.
You know,
Okay.
that'd be a new way to greet people. Hey, how you doing? What's your latitude?
What's your attitude and what's your latitude?
Yeah, what's your attitude? That's going to be my new phrase. What's your attitude? What's your latitude?
All right.
I like it.
Yeah.
What's on your mind, Diggy? We're just chit chatting.
Yeah, nothing. Just I got a call from my cousin, and I was talking to him. Then I remember, like, okay, it's Sunday, right? So I have to get back to the meeting because I almost missed it. Yeah.
Is it
Yeah,
Sunday right now where you are?
It's Saturday evening.
Saturday evening, right? Okay.
Yeah. So yeah.
Yeah, Diggy's exactly 12 hours from me in California.
Yeah.
And so 15 hours from me on the US East Coast.
Or actually, it would be 9 hours from you.
I'm going the wrong direction? Yeah, you're right.
Oh, I don't know. I think 9 hours.
Yeah, it's
that-
10:07 p.m.
No, 15. You're right, Barry. No, you're right.
Yeah.
So
I'm dyslexic.
it's coming up on noon here and 7 p.m. where Diggy is.
No, it's
Yeah.
10:07.
It's what?
10 p.m. It's
Oh,
10:07.
it's getting closer to midnight. Okay, yeah. So
Yeah.
so
Yeah, I'm dyslexic, Barry. I flip things around. So I didn't. You're in my mind, you're behind me, but really you're ahead in time.
yeah. Here it's coming up on noon in less than half an hour, 20 minutes. It'll be noon here.
I always forget that. Like that's the one thing I notice with these GCC calls is like Alex will come on and it's 2 a.m. for him
Of the next
And
day.
of the next day. And I've tried to do Zoom calls with my regeneration pollination group at 2, 3 in. And I'm like half asleep. Like I'm not really there.
Yeah.
It's just too late for me.
Yeah. Yeah, that's one of the problems with this worldwide real-time communication is that you can be 12 hours difference or even, well, can you be more than 12 hours different? I think that's the maximum, 12 hours ahead or behind. That's the maximum difference you can have.
I think where me and Sam got on the wrong foot is back when he would do his Saturday meetings, a group of people around the world would come and then they decided to start their own meeting, but they didn't want to do it at the same time as Sam. So they did a 6 a.m. meeting California time. So I would have to get up because I was off the grid and start the generator in the morning because there was no solar power.
Oh, geez.
So I would get up in the middle of winter, start the generator, do a 2-hour call with those people, and then get on the call with Sam at 8 a.m. And by that time, I was just annoyed and pissed off and in a bad mood.
Not
And then
having a
Sam would
good
be
day.
like, "Oh, your internet's not working. Okay, screw you, Josh." And I'm like, you know how much effort I put in to get here at 8 a.m.? Like, I put in so much effort, and it was just I felt dismissed. So I built up resentment. Yeah.
People want technology systems to be turnkey and plug and play. And I don't know if I said that here or not last week, but turnkey and plug and play are marketing terms and they are lies.
Well, they are when you are trying to use the technology in a way that is not turnkey and plug and play.
Yeah.
Meaning,
And very often, yeah.
it just, I think only in my opinion, and I could be wrong, but just since 2019, it started to be actually like there's the first time things started to be plug and play for me. 2019.
Yeah, they are getting better at it. They're getting smarter and smarter systems that can resolve all these oddball cases. But yeah, it's true that for a lot of what I do, turnkey and plug and play is just completely out the window. I'm trying to do do hackish things that are making old technology able to do modern stuff.
Well, they really got like, I think it was one of the Google routers I bought was the first time I pressed all the buttons and everything worked.
Yeah.
Where I just said, okay, I got the router, and then it said the first thing that popped up when I downloaded the app was point your camera at the QR code at the bottom of the router. And then it just all worked. And I was so amazed. I was like, oh my God, it just worked. What? And it had really cute graphics, and it worked. And I couldn't believe that was the first time I installed a router where I didn't have to sit and fiddle with it for a couple hours.
I'm so used to doing things, the hard engineering way, network planning. I mean, I did network planning for a living for the telephone network. And, you'd spend, months planning for the introduction of one new widget into the network. I spent several years just planning for the introduction of echo cancelers into the telephone network. That was a big deal.
What are echo cancelers?
So before they had echo cancelers, the way that they avoided echo on a telephone call is that two ways that they did it. One is they would put enough attenuation, round trip attenuation, that the echo was there, but it was so low you didn't hear it. But then if you had a very long time delay, then you could still hear the echo. So then they put in echo suppressors. And what an echo suppressor did is it says, if I'm talking, turn off the return path. And when I stop talking, turn it back on again. So only one person could talk at once, because echo suppressor basically shut off the return path, so you couldn't hear the other person. And then eventually, with digital signal processing and fast digital signal processing, they said, okay, I'm going to take the outgoing signal, digital, and I'm going to subtract it with a certain delay from any incoming signal. So it literally waits for the echo to come back and subtracts out with a delay the outgoing signal. So that basically cancels the echo, but lets everything else come through.
That's amazing.
And and actually I worked with the guy who invented it, Don Duttweiler at Bell Labs. I don't know if he invented the concept, but he basically reduced it to devices. And so they were going to replace all the echo suppressors with echo cancelers. And I had to do the study to work out the deployment plan for echo cancelers. And so I became very aware of the magic of echo canceller technology. And that's Zoom, and all these systems use it. So when I'm talking here on Zoom, it's keeping track of the digital voice signal going out, and will subtract it from anything coming back, which is why you don't get feedback.
I always wondered how that worked.
It's built in echo cancelers, and the modern desktop computers and the modern smartphones have enough processing power that they can implement the digital signal processing required for echo cancellation.
I wonder is that on modern music equipment for when you're a performer and you perform on stage, you have usually a speaker facing you so you can hear yourself.
Yeah, the monitor.
So you would think, the monitor speaker, and you would think that the microphone would pick that up.
Yeah, and the microphone, it's not that the microphone doesn't pick it up, it does. The microphone will pick up the sound coming out of the loudspeaker, but it's processed through a digital echo canceller. So it says, oh, that's my own original signal, so I will subtract it from the feedback so that I won't get a feedback loop. And so at modern monitor speakers, just like I'm here on my Zoom, I've got a speaker, I'm not using headphones. So when I'm talking, there's nothing coming out of my speaker that's going to, it basically keeps it from coming out of my speaker, my own voice.
So the modern monitors have that?
Any kind of modern system that wants to avoid audio feedback uses some variety of echo cancellation.
Wow.
Yeah. In this case, when I'm talking, my voice does not come out of my loudspeakers.
Mm-hmm.
but your voice does. So it's basically subtracting my voice from anything, going round trip. So it's not the same as echo cancellation. It's really local voice suppression. But if I wanted to hear my own voice, then it has to switch modes to echo cancellation so it doesn't get a loop.
Oh, okay. So that's why when you hear those old timey things, you hear the echoes, or is that?
Yeah, and also if you remember, they would feature reverberation on purpose. And reverberation would take the audio that's coming in and replicate it just a shade, a few milliseconds late. So it sounds like you're in a room with reverberation off the wall. So you had electronic reverberation, which is intentional. But that was not done with digital signal processing. That was just an ordinary analog delay, a very short analog delay, and then mix in the same signal with its own stuff delayed a few milliseconds.
Right. When I used to do music recording, one of the tricks in hip hop is people would use the echo digital or the reverb.
Yeah, reverb.
But one of the tricks that we used to do is we would just take the track of the audio, duplicate it, and slightly move it, just so you can get the right amount. Like there's like a little trick in hip hop where when you hear it, you know it, but it's different than reverb or echo.
Yeah, so there's electronic reverb and overdubbing reverb. So for example, Les Paul pioneered overdubbing. So he would play back the music and add another track on top of it. And that was overdubbing, which is not the same as reverb.
Right.
But so all these concepts of overdubbing, reverb, echo suppression, echo cancellation, they all have the same idea, either adding or subtracting this, the other channel. And the trick is real-time echo cancellation. That was the hardest of all of those varieties to make work so that you didn't get audio feedback, the squeal.
It's really fascinating. Like sound is something like I could never get bored of making music. Like it's just so amazing.
Yeah. Unfortunately, I don't have the talent to make music. I can't carry a tune. If I try to sing, it sounds awful. I can't play an instrument. I have no musical talent.
But you don't need talent anymore, Barry. You just connect it to a vocoder and it will hold that note as long as you put the parameters. You can make it hold it longer or shorter. You can make it auto-tuned.
Yeah, auto-tune is something that is similar digital signal processing, where it'll take your off-key singing and adjust it so it's on key. Now, how the hell it knows what it's supposed to sound like?
It's pretty simple, actually.
How does it know if I'm singing an incorrect note? How does it know what note to adjust it to?
Well, when you're making music, you know what key you're supposed to be in.
Yeah.
So it'll know if you're not in that key. And in other words, if you ever tuned a guitar, have you ever done that before?
Well, I know what's involved with tuning a guitar, but no, I don't own one. I've never tried to tune one, but I understand the concept.
Yeah, if you just get a guitar just for fun and open up a little tuner, and then on the fancy digital tuners, it'll tell you exactly what frequency it is, like 176 hertz versus 178 hertz.
Yeah.
And when you start tuning it and changing it, you'll start to see, okay, the computer can just pick what hertz frequency it is and take the other, like you're saying, it'll just take the sound and put it into that hertz.
The thing is that if I'm supposed to be singing a note in A flat and I'm off by A flat by less than a half note, it will bring it back to A flat. But if I'm off by more than a half note, how does it know what note it was supposed to be?
Well, that's the whole point, is it doesn't know, and that's why it sounds so weird, because it flips up and down.
Right.
If you're going high or low.
Yeah. So auto-tune only works if you're pretty close to the right frequency, but if you're off by more than half a note, half a musical tone, then it will go to the nearest correct frequency.
So that's the fun of auto-tune, the flipping back and forth when it goes, that's part of the, I mean, literally in hip hop, that's part of it. That weird robotic sound is part of it. If you're really bad, they made it so that the bad sound is now the good sound. That
Yeah.
flipping is fun.
But you're still singing the wrong notes. You end up,
Yeah, absolutely.
yeah.
You're completely wrong.
So my ability to sing on key is so far off. I would be off by multiple notes, and it would just be grating on the ear if I try
Well,
to do
as long as you can hold so the key to auto tune, if you can hold the wrong note long enough, you just have to hold a note, not the right note. Just hold it long enough,
Mhm.
and the auto tune will tune it properly.
Yeah. Now there is a system where it knows the musical score that you're trying to do. And so if it can figure out where you are in the score, it can correct it to the correct note according to the pre-printed score. And I don't know if auto-tune can be fed the score that you're singing and can keep track of where you are in the tune. I know there was a guy at the Media Lab that was sort of working on that. So for example, if you were singing, it could play a synthetic piano that was in tune with your singing, but you had to be singing in tune. But it would back up your original music on a synthetic instrument.
So if you think of it from mathematics, there's X and Y and the Z axis, like the third. So think of up and down and side to side.
Yeah, timing and frequency. Yeah.
So I'm saying the up and down is the high and low of the note on pitch or not on pitch.
Yeah, pitch and delay.
Yeah. So you're up and down, just like up and down.
Right.
Then you have time stretching, and when you stretch it out, then you can. There's some really cool stuff where if you miss the end of the right where you're supposed to end, you end a little early.
Yeah.
You can time stretch it, and that's what's really fun in music.
Yeah, they do something like that on radio. They will, if there's a gap, if I'm talking and I have a gap, it will close up the gaps so that the original recording of a piece that's a news piece might have been 37 seconds, but it'll compress it down to 30 seconds by cutting out the gaps.
Yeah.
And you can tell because when they read a story live, you could tell that it was live. And then when you heard the replay of it an hour later, it was much cleaner. And you could tell that it was cleaning the thing up and cutting out the gaps.
Yeah, I started thinking about science. I was watching a pseudoscience thing yesterday, and it's one of those ancient alien guys that's trying to figure out how the universe works. And he was pulling in real science, but then just sort of manipulating it to his narrative.
Yeah.
And it was like fascinating and then stupid, and then fascinating and then stupid. And he was just talking to a crowd that was, below his intellect. But some of the things he was saying was really like on point. And then he just changed it. Like he was saying how if you go to the NASA website, you can get the actual sound of all the planets, which is true. I've done that.
You get the sound of a black hole too.
Yeah, you can get these actual sounds, but then he was saying, he made some claim that was just so ridiculous that therefore you have all the energy, the information. Oh no, this is what he said. He said, if you slow it down, you can hear a conversation between the planets.
Well, as a metaphor, yeah. Because
as a metaphor, but it was just like, and everyone in the crowd went, "Ooh, planets talk to each other."
Well, in a sense, they interact with each other because they send signals, and the signals can have some effect. For example, the sun will shine on the moon, and the moon will reflect it back to the Earth. So that's kind of a relay. The moon is relaying to us the sunlight. So it's in the dark. We're on the dark side of the sun, but the moon is reporting what the sun is shining,
Right, but the moon doesn't have a diaphragm or a tongue, so it's not changing the sounds to sound like English.
Correct. All the moon is doing is it's glowing in its own native glow in the direct sunlight. Now you could imagine that the moon could be modulating the sunlight. But of course it's inanimate, so it doesn't modulate. But theoretically, you could put a modulator on the surface of the moon that would modulate the sunlight and send information that the moon was originating, modulating the direct sunlight as the carrier.
Do you think the perturbations on the moon with the craters could be different echoes coming out, or like different refractions of the light hitting the craters? Or
well, if the moon, I mean, first of all, when the moon doesn't really rotate with respect to the Earth. You almost see the same side, but it's not perfect. The moon actually has a slight wobble. So what happens is the features on the moon will drift left and right a little bit. And so in that sense, it is modulating. The surface of the moon is modulating the direct sunlight because it's not a flat, the moon doesn't have a perfectly flat uniform surface. So in that sense, yeah, it's modulating the sunlight by setting back its own image. We see the image of the moon because of the surface.
Yeah.
We see the surface features. So that's modulation. It's just not time varying. It's virtually static modulation.
because his whole theory, the whole talk was based on the quantum, the double slit experiment. So he's taking the idea that a particle is a wave and a particle, the light photon is a wave and a particle at the same time, but he's extrapolating that out to say that your house doesn't exist unless there's an observer to be at the house to make it exist.
Yeah, that's like, if a tree falls in the forest and there's no one there to hear it, does it make a sound? And that conflates hearing with sound pressure waves in the atmosphere. Yes, there are sound pressure waves in the atmosphere. The fact that there's no detector, human detector to hear it, it depends on what you call a sound. Does a sound exist if there's nobody listening to it? Well, there's sound pressure waves. They're there.
Right. So in his idea, the universe doesn't exist unless there's an observer.
And that's the mistake that a lot of people made in quantum physics. Because in quantum physics, when you take a measurement, the measurement that you take isn't a complete measurement. You have to choose. It's like when you face your camera to take a picture. The picture that you get depends on which way you aim your camera, and so you don't get the whole story. You get a story that's constrained by the configuration of your camera. And so measurements in quantum mechanics have that constraint. You get a limited amount of information by taking a measurement, and that's all the information you can get, because what's going on in the other direction, you simply don't get that information. You only get that information. So choosing which way to point the camera when you take a snapshot, how you can get that you otherwise could have gotten. And one interpretation is all the other information doesn't exist, which is nonsense. It just meant it wasn't accessible to your instrument.
So the way I looked at it is like a hologram. If you take a holographic picture and put it onto a glass, put it onto glass, you can't see the hologram unless you shine the light at the same angle you took the picture on.
Right.
So
for example, if I want to see behind my monitor, I got to look around the edge of the monitor. So it doesn't mean that the stuff behind the monitor isn't there, just that it's being blocked. And if I have, multiple cameras in space, the ones on this side can see behind the monitor, the ones on that side can see behind it. If I can capture all that information in a hologram, then when I look at the hologram, I can do the same thing. I can look around, and see behind the object. And that's an interesting trick.
Yeah. Do you think we live in a holographic universe at some substantiated point? Like, what do you think of that concept of it's a hologram, but as we move around, we're seeing it meaning it's vibrating atoms and our eyes are detectors and we're sensing it and taking it in. But if we could actually see it on other wavelength, in other words, we're only seeing visible light, basically.
Well, we're only seeing visible light. So you can buy an infrared camera or a UV camera, like the Webb telescope has an infrared camera. So, the fact that our ears can only hear certain frequencies of audio, like 20 hertz to, I don't know, 20,000
10,000.
hertz, that our eyes can only see visible light, but we can feel infrared. You put your hand next to a radiator, you can feel the heat. So you have infrared sensors, but they don't image. They only get you the, the basic energy. So yeah, I mean, we have bodies that have limited ability to perceive information. So for example, I have a radio behind me that can pick up radio waves, but I don't have a radio receiver up here. The radio
Or
waves
do
are going
you?
right.
Or according to this guy, you do.
Some people actually have ability to sense magnetic fields. Birds do, and there are people who
humans do too. Yeah.
There are people who can claim to sense by a compass which way is north, and you have to have a little bit of magnetite. I think in the birds it's in the nose, and they have a little bit of magnetite mineral, and they can sense that, and they can work out which way is north. And some humans have that ability, but I don't know if you can learn to sense it if you don't have the magnetite. You have to have enough of something,
That was his whole postulate, is that humans had more of the magnetite and they've lost it over generations.
Yeah, because if you don't use it, your body is not going to waste resources developing a receptor that you're not using.
Right. Like our sense of smell probably thousands of years ago was much stronger.
Yeah. So basically you spend your resources on things that give you viability, and you let the other ones go by the wayside because they're not useful. So we end up having to invent the technology to get radio waves. Oh, by the way, when you ask yourself, how big is a photon? Is it a point particle, or is it? When you think about radio waves, like AM radio is like 1,000 kilohertz, which is I think 300 meters. But so the wavelength is 300 meters, and the electromagnetic field, the Maxwell electromagnetic field, extends in space quite a ways. Which is why when you make an antenna, your antenna has to be a piece of wire that's that long. It has to be about a quarter wavelength long. And the same is true of visible light. The EM fields for visible light cannot, by definition, be a point. They have to extend in space. Otherwise, how could you have an EM field that could be, detected? So the answer is, when you go through the double slit, the EM fields of the photon are actually spread out in space, and they go through both slits, and they refract and diffract.
Right.
There's great video of a young woman who's doing experimental science. She had a laser.
The Indian lady that put the piece of hair?
Yeah.
I just watched that the other night.
She took a strand of her hair with a red laser, and she put smoke so she could see the laser beam, and she proved that when she shined the laser at a strand of hair, that it spread out. It made a cone. And she could
I thought I heard Diggy want to chime in. Please chime in anytime, Diggy. We're loud Americans talking loud.
I've studied that thing in my, undergrad and postgrad. Yeah, it's a really fascinating thing.
If you have any thoughts, please chime in, because I thought I heard you, but I couldn't tell because my headphones.
Yeah, no, actually, what Barry's bringing up is, it's like really, I would say, really clear point of view. Actually, even I got some really deep insights into it, like that analogy where you said that, okay, the picture is actually, the picture depends upon the camera angle that I'm keeping. Right. So yeah, I think these things are actually these things are very sophisticated, and when you're trying to tell people that what it actually is, and you just dilute it to their level, they actually end up being misinterpret these things, and they have just this amazing ability to romanticize fiction. So yeah, that's what they
extrapolate that fiction to more fictions,
exactly.
and then extrapolate that fiction to more fictions.
Yeah, the other day, some dude was, trying to explain me, some quantum physics, and I said he was, spilling bullshit out of it, and I just told him that I do experiments based on that, and there's nothing as weird as that I've ever experienced in quantum space.
Yeah.
Because, just to make people understand, people actually dilute things down, and which leads to, I think, actually misinterpretation of the facts. I think that actually happened a lot when, there's a movement when people try to make things easy. So they started by giving examples, and most of the time examples are not 100% correct. So yeah, that just sabotages the beautiful concept, to its core.
Yeah.
So I think, yeah, there has to be a boundary line where, where these examples or this explanation has to be, tested, because it just, even I came to know about a lot of things, right now. And I was like, okay, I was told in a very different way. And yeah, I might be missing some pieces here and there, we need some, very good insight to it. That's what I think.
And some good experiments. Like when I was at the Science Museum, they would have a wave experiment where they would show how the waves cancel each other out. And
Yeah.
like little wave pools, like actual water, you put the thing in and they had do you remember that
damping.
machine? Did they still have it, Barry, at the Science Museum where it
The
made
wave
waves?
machine. Yeah, the
Yeah.
big water tank, the long water tank with the wave machine. Yeah.
Yeah, that's
Yeah.
how I learned it as a kid.
Yeah. So, but the understanding, the difference between a traveling wave and a point particle, everything turns out to be a traveling wave because the quantum field theory says that what we call a particle is actually a disturbance in some wavy medium. And so when you think of them as a particle, it's only because when the energy of the wave interacts with matter, all it can do is one electron can end up capturing all the energy of the wave of the quantum. And so so here comes a radio wave in space, and say one photon of the radio wave, one packet. Somewhere it can give up all of its energy to one electron, which then changes its orbital.
Uh-huh.
Yeah.
And then,
Yeah.
so now that electron is in a higher energy state, and that electron says, oh, you can have it back, and it drops back down. So it re-emits a new photon of the same frequency, but not in the same direction, which is why when you have diffraction, you send, here comes a photon. If the EM field is at the right amplitude, the right phase, it can kick an electron in the material. It can kick an electron to a higher energy level, and then a nanosecond later, that electron says you can have it back, and it emits essentially it repeats the photon, but in a different direction, which is why you get diffraction. So it's not that the photon itself bends; it's that it transfers the energy to one electron, which then gives it back to a new photon, which now goes off at an angle. And that's how you get diffraction and refraction and all that kind of stuff. Like, so if I shine light on my wall, the paint particles in the wall will accept the photons of light, excite themselves up, and then radiate it back out again. And that's why the color of the wall is not the color of the sun. It's whatever color the paint is. The paint particle says, one of my electrons got excited from the sunlight, and then it gave it back, or gave some of it back. And so it's not the same photon. When you put up a mirror, the photon that comes off of the mirror is a new photon. The photon of the original light source excited the silver in the silvered mirror. One of the electrons in the silver got excited and then gave it back. And so you get a reflection, but it's a new photon. Same energy.
When you say it's a new photon, meaning it's a new dispersion of that particle itself, meaning it's like, in other words, what is the heat? Is there a heat transfer?
Yeah, that's what I want to ask.
If the photon is absorbed and not re-radiated, then what happens is the paint particle starts physically vibrating. That's heat. Alternatively, the electron in the paint particle can accept the energy of the photon and then quickly drop back down again and not turn into vibration. And then, so that's a new photon of light comes out, or the photon is captured and not get warm. It's one or the other.
Yeah,
Got it.
I think that's black body radiation, right? When the photon is captured.
And then if you get this kind of heat, then that comes out as infrared, because that will radiate heat as infrared. And then you can cool down by radiation. So you have radiation in a different wavelength, which can be infrared radiation. You can have radiation in the visible wavelength, which is the color of the molecule that absorbed the original photon. And if it's silver, which is a metal, it will the electron will capture the energy and play it back at exactly the same wavelength, but in a different direction, which is why you get a reflection in the mirror. Here comes the photon, and there goes the new one. But it's the same. It's the same color.
And the direction is always the same because of the color, or because of the properties of the electron?
Because the electron in the silver being a metal, the electron is not bound. The electron is not bound to. The electron is not orbiting a molecule in silver. It's a metal. So the electron starts moving, but then it radiates because.
Okay, so Barry, I have a question that when a ray of light is striking on a mirror at a certain angle, the angle of approach is equal to the angle of reflection. Okay, so what is it? It's the it's the most of the photons are is following that path. Or
well, here's the interesting thing. Feynman gives a really interesting explanation. The photons that are coming from the light source are hitting the mirror everywhere. Okay.
Yeah.
And
yeah, exactly.
And they're everywhere that it hits, it can send back a new photon, but all except for the one which is right at the angle of incidence and angle of reflection, all the others are out of phase with each other. And he shows that if you chop up your mirror into these bands, and you can even take away the one at the center, you still get a reflection. That's like a Fresnel lens. And this is amazing. He shows that the photons coming in here, you can get some of them. Photons coming in here, you can get some of them, and so on. And most of them are canceling when they get to the receiver. And he has this whole hour-long video that explains that and shows that you can chop a mirror into strips and throw away the middle one, which is where you think the light's coming from, and you still get a reflection. But you have to choose the strips where they're arriving back in phase.
When you say chop the mirror in strips, do you mean in which direction are you chopping the mirror?
So here's the light coming in.
Right.
Okay. So let my fingers be the strips of the mirror. So normally you think, well, the mirror is reflecting from this point.
I see.
But it's actually reflecting from all these points except here, this point, they're coming back in phase. Here they're out of phase. Here they're in phase. Here they're out of phase. Here they're in phase. So if you cut away the parts where they're out of phase and you leave the parts where they're in phase, it doesn't matter that this angle of incidence and this angle of reflection are not the same anymore. And what he does is he throws away half the mirror and he leaves these outliers present, and you still get the reflection. And that's an amazing demonstration that Feynman does in his lectures that is almost never taught. I never saw it except Feynman's lectures. But a Fresnel, you can make a Fresnel mirror that actually does that.
I'm trying to remember, Fresnel mirror, is that the one they used in lighthouses?
Well, that's a Fresnel lens, which is Again,
Okay.
again, the position of the lenses is at the correct spacing. So that basically you only need the portion of the glass where the light coming through is going to come back in phase. And you leave out the glass where you don't need it. Where it's out, the part of the glass where it's going to come back out of phase, throw it away. Don't make that glass. So Fresnel lens is like a lens which is concentric circles. And the only parts of the concentric circles that you keep are the ones that where things are coming back in phase. There's their
Got
focus.
it. So instead of chopping it, you're making grooves in it. Is that what you mean by
Yeah.
concentric circles?
Yeah, so you have all kinds of devices where you have either concentric ridges or polarizing filters which have vertical lines. And if you design them right, they will basically do what you. So the question is, how is it that if you send light that's polarized this way through a filter that's polarized this way, why does the light that comes through all end up polarized that way? And the answer is the photons hit the material of the polarizing filter. The energy of the photon gets absorbed by an electron and then immediately re-radiated, but now it's re-radiated with the E field going this way instead of that way. And so you can line up 100 polarizing filters, each one slightly rotated a degree from the others, and you can rotate a vertically polarized light beam to horizontally polarized, and you don't lose any energy because you have each of them is just another degree.
So
And that's been, you can do that in a laboratory.
Doesn't that reduces its intensity?
A little bit, but you can basically keep about 90% of the intensity if you do it step by step by step by 1 degree steps.
Okay. Because we have this physics problem in our in our physics exam, the same one that you have these filters, polarizing filters, and they are kept at a certain angle. So how much intensity is there, which is left behind?
Right. So normally you have one vertical, 145 and 190.
Yeah, exactly.
And when you put the middle one in between, you get about, what is it, half the energy or fourth the energy. But if you do not just one in the middle, but you do a whole bunch of them in the middle, each one just 1 degree around, now you lose almost nothing.
Okay, that's interesting.
And there's a very nice video where they show that in these videos that talk about, these intermediate polarizing filters.
I would love to,
Barry,
I would love to read your work plus your, YouTube playlist, because you always come up with the most exciting videos of all time. So is there any other way to, reach you out?
Well,
we have to wait.
The stuff that I write up is not other people's work, which I've bothered to understand. It's my own research, my own independent research I've written up. And the last piece of work that I did before I retired that I bothered to write up and get peer review and so on was a theory relating emotions to learning.
Wow.
And that's my 2 big contributions were my PhD thesis in the 1970s, and then this model relating emotions to learning, which was in the 1990s, basically. And that is published on the internet. And as far as I know, you won't find any other presentations of that material.
So
well, you found that one guy that was into it, right? I remember he came on the call, but that was you. He was into your work, or did he have his own ideas on emotions and learning?
Can you remind me who that was?
I'm trying to remember. There was a lady you met, and she had a brother who was also doing the same type of research, and then you guys met, and I thought he came on a call one time.
Yeah, I think I know who you mean. Paul Ritchie.
I don't remember the name.
Yeah, Paul Ritchie was a guy at MIT. He's graduated now, and he had a very similar idea, but he hadn't written it up. At least I don't think he had written it up. But he somehow became aware of my work and he says, I've been thinking along the same lines. So I think he understood it, but as far as I know, he has never turned around and echoed it back replayed it back on his own. So there are people who understand it. When I presented this model at an international conference in early 2000s, at a conference, I got the best theory paper award at the conference, meaning the people who vetted the papers and thought this was really great theory. But it's a little bit like any new theory in science. The person who introduces it, it's their theory, and almost nobody recreates it afresh. They basically, if they learn it, they'll replay it. But and it's a kind of an arcane theory, because how many people care about mathematical theories relating emotions to learning?
Well, I think now it's a hot field because of the AI machine learning. When you take an algorithm for machine learning, they're not programming in the emotional aspect of the machine.
Correct. So the idea is a really good teacher will pay attention to how much of the material the student has correctly learned, how much of it have they learned poorly, and how much of it have they not learned at all. They'll pay attention to the cognitive component, but they'll also pay attention to the emotional states that attend the degrees of learning, and they will modulate the tutoring or the mentoring as a function of both the knowledge and the affective state. So you have,
right.
So here you have the learning and the unlearning, the correct and the incorrect, and then here you have negative and positive emotions, and where you are in this quadrant is how you adjust your teaching. But if you're only paying attention to this and ignoring that, then your tutoring is what's the word I'm looking for? Degraded, not necessarily effective. You're saying you got that right, you got that wrong, you didn't know this at all. You're basically telling them what their knowledge state is, but you're not modulating the presentation as a function of their affective state. And if you can get their affective state, if you can detect it, then you can adjust your mentoring approach so that it's optimized for where they are in this two-dimensional space.
I would think in the ed tech world, that would be something that would be very important to account for.
Exactly. And the conference that I attended where I first presented it was called Intelligent Tutoring Systems. It was all about intelligent tutoring systems. And when I said,
where was the conference at?
This is Madison, Wisconsin in 2001.
I was going to say, you need to go to my friend is an ed tech, one of the top ed tech guys, and he went to Japan and they loved him in Japan. Like, they would be more receptive to that, I think, in the Japanese culture.
I have been looking, for example, in high school, advanced placement math, they will teach calculus as an elective advanced placement course for seniors in high school. And I took advanced placement math in high school, and it was calculus. And then I again took calculus in college. But here's the thing, if you're going to teach calculus, say at the senior level of high school, you basically will begin by teaching the mathematics of ballistic trajectories, Newton's ballistic trajectories. So the first use of the calculus was the use for which Newton invented the calculus, which is to calculate parabolic ballistic trajectories, right? And that's fine, because that's sort of the very first application of calculus. But if I say that very same model of calculus to do ballistic trajectories, the first and second derivatives and so on, what if I say it's not the motion of an object moving under acceleration, it's not the journey of a baseball or a bullet, it's the journey of a learning machine, learning system.
Right.
So when you have learning, you draw a learning curve. You draw a typical learning curve. So over time you gain knowledge. Okay, but a learning curve is curved. It's not linear. You don't learn at a fixed rate. You learn at a steep rate at beginning, and it kind of curves. So the learning curve has a slope which changes, which is the second derivative. Okay, and in calculus, that's the acceleration. You have the velocity and the acceleration, right? You say, well, what is the curvature of a learning curve? Well, it's the second derivative, but what is it? And the answer is it shows up as emotions. How do you reckon? So for example, suppose you have a misconception. So you're laboring, you're building a mental model, but it's a misconception. And so what happens is that as you're using this misconception and anticipating what's going to happen, what turns out to happen disagrees with your expectation because you're working from an incorrect mental model. So what happens is you eventually maximize your incorrect mental model and you realize it's not predicting the truth anymore. And so you have to start throwing it away. You have to start.
What about expectations though? In the person that you're teaching, the expectations, meaning from what I understand about just the way the brain works, is in a conversation, a person, like I have this happen all the time. A person is expecting you to say something, so they've already jumped to the conclusion. Thus, they've closed the off and on switch of the actual listening. So they're not actually hearing the knowledge, so the knowledge doesn't get in. Does that make sense?
Yeah, what happens is that I already know this, so I don't have to listen to a new lecture on it. And so what if they're laboring under a misconception, which they don't realize, then they will hang on to their misconception by shutting off the updating. It's like saying, I don't need to update my computer. I love my operating system. The fact that it doesn't do everything that it should be able to do, never mind, I don't need the next edition. Right? So what happens is people get stuck with the version of the operating system that they finish with, and they don't do updates. And so the operating system doesn't do things which you could have done if you had updated it, right?
Well, there's the point is, I talk to a lot of autistic people or people on the Asperger spectrum, and it's a different conversation. Like I talked to my sister the other day, and she just said, well, who cares?
Exactly. Who cares if the orbit of Mercury is precessing? Who cares?
Who cares?
I don't care. I don't care if Newton's model incorrectly predicts the orbit of Mercury.
Right.
I don't care if I incorrectly predict when the eclipse is going to happen. Well, people who do care say, my prediction of the eclipse came out, I was off by, a day or an hour or whatever. Why is my mental model departing from observation? And I want to fix that. If I don't care, if I say, I only want to know what time it is to the nearest 5 minutes, why do I need to? So I'm 5 minutes early or 5 minutes late to a meeting. Who cares? Okay. And yes, people say, I don't need to have any more precise knowledge. I'm driving down the street and there's another oncoming car and I misjudge it by 2 seconds. Oops, that was the time I had the accident. Because if I had not misjudged it by 2 seconds, we would not have had a collision. At some point, you realize that the discrepancy between your expectation and reality matters. At some point, it matters. And then you say, okay, now I have to adjust my model so that I can account for this small error.
I learned that when I was a kid. I used to try to run across Massachusetts Avenue.
You misjudged.
Because I didn't want to go. I didn't want to go to the light. And so I would plan, I knew how fast I could run at that moment in time. And I would go 1, 2, 3, go. So I could go between the cars. And one time I misjudged it and I had to run back like a squirrel in the road.
Right.
And exactly. I realized, you know what? I got to stop playing this game because this is a life and death game and I'm going to die as a kid.
Eventually, the simplified mental model, which was adequate for a certain amount of time, becomes inadequate. Yeah. And so one of the motivations is it becomes life and death. You have a near miss or a near, a near collision. So, but the point is that the curvature of the learning curve encodes information, and curvature of a graph is simply the second derivative. And the question is, if you take a learning curve and it curves, how does that show up? And it basically shows up as emotions, confusion, surprise, disappointment, disbelief, consternation, because what you expected to happen didn't happen. And so you have, whoa, what the hell,
isn't that taught early? Like I'm watching my daughter right now learn that to manage her emotions.
Right.
her expectation,
Yeah.
like I don't know why I'm telling this story, but every morning when I get my coffee or my tea, if she sees me with the glass, I let her stir the glass. So if I get my coffee and I don't let her stir it, she gets really angry, really frustrated because she
Right.
goes, "Oh, this is coffee stirring time." And she yells at me, "I got to stir your coffee."
Exactly. So she has expectations, and when they are not met, then she has a negative emotional reaction. And
Well,
the point is,
she doesn't know how to interpret that reaction. She's learning, is it negative? Is it positive? Is it happy, sad? Like all
right,
those expectations, how to, in other words, if you take out emotions and you just do the analytical of the expectation, how do you, like, that's what I'm learning by just watching her grow up is the management of the expectations and what it turns into emotionally is part of her development as a human being.
yeah. And some people have meltdowns. If their expectations aren't met, they have an emotional meltdown. That's sort of the most extreme autistic has emotional meltdown. And the most stable person says, well, that's odd. That's what I'd expect.
Yeah.
And they'll articulate that that's what I thought was going to happen. And they'll have a conscious awareness of it as opposed to a physical meltdown or emotional meltdown. So the ability to recognize your emotional state and say, that's odd. Why did that happen? That's an anomaly. There's something
So
happening. Something's happening here, which I don't understand.
right, that's the
So now
vexed
you're
and perplexed.
motivated.
That's that state of vexed and perplexed as opposed
Exactly.
to the state of
Who
angry
cares?
and
Yeah.
mad. Yeah.
So if I say I'm vexed and perplexed, and maybe your sister will say, Barry, who cares? Just go with the flow. But the thing is that if you're a scientist and you care about accurate mental models precise, then you do care.
Yeah.
And for the reason that you explained, that at some point this misconstruing things could be a serious downfall.
Yeah.
Okay. So the point is that when I looked at the curvature, I said, well, that's just called the second derivative in calculus. Oh, but that shows up as perturbations in your affective emotional state. Criminally, I can now motivate the teaching of calculus, the function, the value of the function, the slope of the function, the curvature of the function. And I can say, never mind that this is a ballistic missile that I'm tracking. This is a learning journey that I'm tracking. I'm using the same mathematics, except that distance is knowledge, rate of gaining ground is not speed, it's learning, and the perturbations in the rate of gaining ground is affect, emotions. And I go, the same math that Newton gives us for ballistic trajectories is the math that I can use to manage attention to a learning curve. And if you labor under a misconception, eventually you throw it away and replace it by a new model. And so a learning curve is not necessarily monotonic. A learning curve can have wiggles in it.
Okay,
And the
so
wiggles
Barry,
are
can you
throwing
say-
away the misconceptions, discarding the
Yeah.
misconceptions, and then replacing them with a more sophisticated model that gets you to a deeper understanding, a higher insight.
Yeah, Barry, this is a very interesting observation. Okay, so the learning curve is just like a parabolic in nature. Okay, so when we anticipate the learning curve, okay, and we found out that, okay, this is where we are getting it wrong. Okay, then we iterate it, okay, with what we think is correct, and then we start it again. Okay,
Right.
so it's that, the wobble that you talked about. Okay, so we are iterating it in a like after every step. Okay, so rather than being a parabolic path which actually eventually dips down, we have this
There's wiggles.
parabolas connected together. Yeah.
Yeah.
So if we join these minimas, right, the local minimas of those parabola, we actually get more closer to the truth, right?
Yeah, because you have become aware that your previous mental model was baloney. So when you
Yeah.
realize that your misconception was baloney and you stop relying on it, that's actually a gain.
Yeah.
You have lost the ability to make a prediction, but you've gained the ability to fail to make a bad prediction. Did I say that
Exactly,
right?
exactly.
So,
That's
so,
really
so,
interesting.
so saying, I no longer am going to make this prediction because I now learn that these predictions are wrong. So I'm going to admit that I don't have a reliable mental model. That's a gain. Now you say, now I want to acquire a more reliable mental model that doesn't make wrong predictions.
Yeah, exactly.
So
Wow.
when you draw the learning curve as with wiggles, then you say this positive and negative second derivative is
Yeah.
learning and unlearning, and it shows up as affect or emotional state. And it doesn't matter if it's a living creature, a human or an animal that's learning, or a learning machine, because a learning machine is not going to learn monotonically. A learning machine is going to form a working hypothesis, test it, find that it's not making good predictions, and discard it. So a learning machine is also going to have this wiggly, wavy learning curve. And the learning machine wants
can
to
I
pay
call out the
attention.
elephant? Can I call out the elephant in the room though? So
The elephant is the thing that's present, which people are ignoring.
right. So the thing that's present is the biological aspect of a human being, meaning Digvijay has different DNA, different operating system, different ways of his body producing chemicals at that moment in time in the wobble. So thus his body could get hotter or cooler, or could have different biological effects that make a feedback loop that change the wobble.
Exactly. So here comes an incoming missile, and you duck. And if you're good, you anticipate it and you duck and it misses you. But if you're poor at reckoning it and you duck and it still smacks you on the side of the face, you say, I got to work on this, this dodge. I have to work on my dodging mechanism because I'm not anticipating the threat and dodging out of the way reliably. And so when you get sideswiped, you figure I got to improve my ability to dodge.
The reason I'm saying this is for me, at least with my daughter, it's a timing thing where if I let her keep getting upset, then her body's going to get hot and she's going to get red in the face and she's going to start, her body is going through the chemical aspect of not seeing reality as truth, which is I'm going to get the coffee stir and I'm going, like, once I tell her that, if I don't show her that, she'll keep getting upset and then there's no way to communicate. Like, in other words, like if you think of human emotions, if I tell someone they're ugly, get out of my face, then they're going to start to get upset, or possibly they don't care, I don't know, but they're going to have a reaction. And how long that reaction goes, where I go, oh, I'm just kidding, I was just joking, or something, or just something to the point where you don't allow them to stew in that anger to where they're going to take a chair and hit you over the head.
Yeah. So if you think
I'm saying
about
timing is an aspect. I'm saying how long that wobble happens is a big part of it.
Right. How long does it take you to recognize that you're living under misconception, decide to stop relying on it, so basically discard it, and then say, but now I need a better model because now I have no model at all, no mental model. So you can learn very quickly and try something out, say, no, it's not working, throw it away, try something out. Or you can say, well, I'll just hang on to this crappy model because I don't want to go to the trouble of learning a better one. So you can have very slow waves or very fast waves, and your best learners are the ones who will try something, evaluate it, throw it away if it's bad, try something else, try 20 different models before they get one that seems worth keeping. And
that you just described comedy, Barry.
Exactly.
No, really, I'm dead serious. You literally described the thing that eludes most people is comedy, is how long you hang on that last thing you said,
right,
and allow for the wobble to happen through the crowd.
Right. Yeah, it's a slow take. Jean-Luc Picard does this video about slow takes, where something happens and you go, and then he says, that's a one slow take. And they go, there's a two slow takes. And then three slow takes. And he shows about this, this triple, quadruple, slow takes on observation, where you realize that something wasn't what you expected. Then you realize the next level of detail, and the third level and fourth level of detail And he does this whole, acting, how you do these multiple slow takes in a row. It's a cute, you'll
Yeah,
find if you do Jean-Luc Picard doing slow takes. Or
Oh no,
whatever.
I got it. I watch a lot of comedy, and I noticed it's like hypnotizing the crowd before they can think about what you said. Then you move to the next subject, or you take them on a.
Right.
It's a narrative storytelling journey
Yeah.
with a bunch of pauses, and
Yeah.
it's like comedy is fascinating.
Puns are like that. Puns are often a slow take. So I will toss in a pun intentionally, sometimes unintentionally, but most intentionally, and it'll be a slow take, like 30 seconds later, they'll realize there was a pun in that, and then they'll do a second take. And a really good literature is like that. That is, there is a second and a third take because there was a subtle subtext, a pun or some kind of subtext that you didn't notice the first time, you're oblivious of it. But then after you've processed the surface level, then you get the next level down, or even the next level underneath that.
So that brings me to my next question: is in your theory, are we talking about only the conscious mind, or do you get into the subconscious mind?
Well, so there, in any learning journey, there's the individual who's doing the learning, and then there's the parent, the coach, the teacher, the observer, the friend who is watching the other person learn. And so the coach might have a higher level of awareness of the learning curve than the individual. So, and that means that gives the coach the ability to be a coach, because they can coach with respect to the element that the learner themselves is not yet attending, still oblivious of. Now, eventually, you want to get to the point where you can be your own coach. How do you do that? Well, you record yourself and then you watch the video, or you or sort of monitor yourself, while you're performing. And so you have to have half of your brain is watching what the other half is doing. But more often than not, you need a parent, a teacher, a coach, a friend who provides the mirror, the feedback. That's why you practice in front of a mirror if you're dancing.
Mm-hmm.
So the mirror can be a coach. The mirror can be literally a mirror, or a video recording, or an audio recording, or feedback from a friend, or whatever. But that gives you the second level of awareness. And that's one of the reasons I like to play with recreational math and recreational puzzles, because you try something and then there's a way to test to see if you did it right. There's yes, you solved the puzzle, or no, you didn't. You were laboring under misconception, you tried to solve the puzzle and it fell apart. So sometimes the feedback is sort of innate. The puzzles are designed to have innate feedback. You either solved it or you didn't. Other things you don't really know. So if you do a performance and you go, I didn't get any feedback from the audience, I don't know whether that worked or not. I got up,
Right.
I did my shtick, and I have no idea. They politely applauded, and then they got up and left. Nobody said, yes, no, or modulate, or do this or do that. Well, we don't get the kind of feedback that allows us to attend to the learning curve most of the time.
Yeah, the feedback is very, very important, I think, in the learning. Like,
that's why parents have a very powerful role to play in attending to the learning journey of a child and intervening at an optimal level of intervention, depending on where the parent determines the child is in competence and affect. And you pay attention to both, and then that modulates how you intervene as a parent.
Yep.
And the point is that there's a mathematical model for this awareness of the affective state and the cognitive state, and that then suggests the optimal intervention. And good parents are very good at that, and bad parents, suck at the intervention.
Yeah, I think you just described good teachers and bad teachers, like in school, the ones that actually give you a feedback. The ones that don't give you any feedback are bad teachers. They just give you a grade and they don't say why.
Or they give you bad feedback. They basically say, no, you're wrong. Get out of my class, which is, terrible. So a really good teacher will diagnose the details of the misconception, the details of the gaps, and then figure out a way to introduce the corrections, the updates in such a way that the learner is receptive to receiving the update, as opposed to, bad teacher, go away. I'm not listening. That's an art, but it's an art
It
that
is
has
an
a
art.
mathematical undergirding to it.
Yeah. So have you tested your mathematics in educational technologies, meaning like do it over a series of years to see if this, like group A does this, group B does that?
So there were three ways that I was able to validate the model. One of the reasons I took up the volunteer role at the Science Museum, and in particular the puzzle activity at the Science Museum, was to test whether I could improve my ability to be a supervisor, a manager, intervener with visitors at the Science Museum solving puzzles. That was one method. The other one was online learning communities like Micromuse. Could I do this with online learning communities? And then the third one was in actual laboratory experiments, which are real studies. And we did, over the period of 10 or 15 years, all three ways of validating the model and then improving the interventions reactions.
Mm-hmm.
And that's in addition to actually just presenting the model as a technical presentation. So it's
Did you
presenting the
publish
model,
those
testing
studies?
the model, improving your ability to employ the model as a good mentor. All of those, yes, we did all of those, some more formally, some informally, some with recording, documenting, some without documenting.
Do you feel that the work is complete? Do you feel like you got the information you needed, or?
The work is not complete in the sense that I don't have a whole lot of disciples who have glommed onto it and say, yes, this model is really useful, and I want to not only use it, but explain it and teach it to my cohort. So for example, I would love if a teacher of advanced placement math in high school, calculus, was using this model as part of the curriculum. And as far as I know,
so
there
no
aren't
one's
any.
understood how to do them. Is there anyone that you've ever come across that understood how to teach the model?
Yeah.
To another disciple?
The first time it happened, I was when I was beginning to use the model at the Science Museum, and occasionally I would explain the model to a parent. So a parent would bring their child in, the child would be working on a puzzle, and I would do the coaching technique with the child, with the parent sort of looking over the child's shoulder. And then depending on how keen the parent was, I would occasionally bother to explain to the parent the concept behind this coaching technique with the puzzles. And I wasn't sure if anybody else could have done that. But one midday I came in, and the morning guy was explaining to the parent the technique that he was using. So that was the first time that another volunteer at the Science Museum picked up on the approach that I was using and could replicate it. And that was the very first time that it proved that anybody else understood the model and understood it.
Okay.
So, and that was in the 90s. But after that, there weren't very many other people who really not only understood it, but employed it and explained it.
Have you heard the story of how the Buddha taught his disciples? Have you ever heard that story? Is that familiar to you?
Not by that name. Run it by me.
There's a famous story where the Buddha, after he meditated for so many years and came up with this model for ending suffering, he ended his meditation, and then he didn't know how to communicate it to others. And he was meditating on the lotus plant that grows in the water, and he realized that some lotus plants blossom under the water, some at the surface of the water, and some above the water. So he gathered a group of people that he thought were lotus blossoms above the water, and he did his famous lecture it's called Deer Park, where he explained all of the precepts of Buddhism in the Four Noble Truths and the Eightfold Path.
Yeah.
So he broke it into a system, explained it to those people, and thus it's spread and it's still around today.
Yeah. Yeah, that's the notion about learning in public versus learning in private. I notice when I'm engaged in mentoring or tutoring or whatever, there are certain people who love to learn in public. They will solve puzzles in public where they don't know if they're going to succeed or not. And there are other people who want to do everything behind the scenes in private before they will come out. And there's sort of people who are in between. And I've noticed this this difference between people who learn in public and people who don't learn in public. And and the people who don't learn in public want private tutoring, lots of it. They want hours and hours of private tutoring. And I say, I would love to give a workshop to a dozen people. And the workshop is that everybody's present in this semi-public workshop and everybody's learning in front of everybody else. And if you want private tutoring from me, forget it. I don't have the ability to give 12 private sessions. I can give one public session to 12 people. And I basically have to turn down the people who want private tutoring in parallel.
Yeah, that's the conundrum. I did a brief stint in the learning thing, and I realized this was my own experience that I put a prerequisite for the class. I wrote the syllabus, but the people that came into the class lied and they didn't have the prerequisite. And I was very annoyed at that. I got really upset about that.
Yeah.
And I was upset more at the institution that gave me the students. So they picked the wrong students for the type of class I wanted to teach.
Yeah. I ran into that problem when I was tutoring calculus. I would occasionally get a student who had earned A's in algebra in high school, and they couldn't do the calculus because they didn't know the algebra. And I had to tell, was one student in particular, I said, your problem is that you got an A in algebra in this tiny little school in Western Nebraska, but in fact, you never learned algebra. And you didn't know you didn't learn it because they gave you an A in it. You need to go back and really learn algebra, then you can begin to learn the calculus.
Right.
And that was really sad. I actually had to tell the guy, I had to diagnose the guy's problem was he thought he could do the algebra, but he hadn't learned it.
Yeah.
And he'd been lied to. He'd been cheated by his little tiny high school in Western Nebraska, who passed him with a high score in algebra, which he never actually mastered.
Yeah.
I think learning in public also helps in a positive feedback loop as well. You know, the feedback is really quick when you learn in public.
In the online learning community on the internet in the 90s, people were learning at a fantastic rate, 5 to 10 times faster than the typical learning rate in school. And the kids who were on it, mostly teenagers, said they loved to learn, they loved this online learning community, and they hated school. And they were learning at this incredible rate. And we saw this time and again where kids were learning at phenomenal rates of learning compared to the traditional rates of learning in the conventional public school system. Josh,
Apologize. It's getting to the top of the hour. I got to.
Okay.
Can you hear me?
Yeah, I can hear you.
Check one,
Yeah,
check
I see.
two.
So yeah, we're getting to the 2-hour mark. Yeah. So, Diggy,
Yeah, I was just saying I got to go check in on the family.
Yeah.
if you want to link to that paper that I wrote on the,
I found it actually, the cognition effect and learning, right?
say that again.
Cognition effect and learning.
Yeah, have I given
Yeah.
you that link before? Do you have it?
No, I just found it out. You know, I
You-
searched it on Google.
The version that
Diggy's
you found
resourceful.
is the version that you found on Google Sites.
Yeah.
Okay, that's the right one. Yeah. It's on sites.google.com/Barry Court.
Yeah.
And cognition
and
effect
it-
learning. And that's
Yeah, and-
basically the summary of the whole story.
Yeah, and I think it's very intriguing and amazing, and I will read it and I ask a lot of questions next time because it looks so amazing.
Yeah, I was going to say, Diggy, can you send it to me just because I don't have Facebook right now, or if you
Yeah,
could,
it's yeah,
if I put my email in the chat, Barry, could you send it to me?
yeah, of course.
Let me just get the link and put it right here.
Yeah. Put it on
Copy
chat.
link address, chat, paste. Right, do you see in the chat sites.google.com, and then at the end, cognition, affect, and learning.
That's
Yeah.
it.
Yeah, just copy that out of the chat.
Got it.
This is the one. Yeah.
That's the best place to go to get, that's sort of an encyclopedia style article on this material. At the bottom, it has all the peer reviewed stuff, but you don't need to go to the back original peer reviewed stuff. It's just the same content.
I think it's
Yeah, before I
really
go,
neat.
Barry, Diggy, we were talking, earlier this week about, oh wait, my phone is dying. Hold on. There we go. We were talking about how to teach. So we were having a discussion about teaching. So this is apropos today. I appreciate the conversation.
Yeah, actually,
So I
it's
would
really,
like to dive deeper. I don't know if I'll have time enough to dive as deep as I'd like to, but it's definitely something that's very interesting
yeah,
moving forward, especially with my daughter. I want to give her a good education.
Yeah.
So thank you.
Yeah. I mean, this sort of stems from Piaget. Piaget was sort of one of the first people to study how his own children were learning. And he began the development of learning theories. And so a lot of learning theory basically stems from Piaget, studying how children learn, his own children in particular. Montessori, the same thing, there were a lot of people who really were pioneers of learning theory.
and I think Barry, your work is going
I'm
to be
going to say
like
goodbye. Thank you so much.
by Joshua. I think
You
Barry,
guys can
your
keep
work
talking, Diggy. I'm just saying goodbye.
yeah. Take care. Have a good day.
So yeah, I mean, take your time to digest. That's a semester's worth of material, Digi. So
Yeah,
take your time in, and then as you work your way through the
Yeah.
portions of it, feel free to ask questions, and we can have some time.
yeah, because the EdTech model in India is actually failing, because I don't know why, because I didn't dive deep into it, but I think I'm like very interested in, doing a startup in EdTech industry.
Yeah.
So like after 2 years or 3, so I was looking onto the stuff like, okay, like you have to learn more about, human psyche than the subject if you are into the EdTech, right? So I
You
think
need to
this thing is going to be like very important for, things to come.
Yeah.
Because we do a lot of things, on auto mode, which we don't even we don't understand that how we did it and pulled it off.
Yeah.
Right.
And you
Because
can't teach
when we-
something if you have something intuitively, but not as an
Yeah.
express theory. You can't
Exactly.
teach what you understand intuitively. You have to elevate it to an express theoretical model in a public language, of which mathematics is probably the most useful public language in that regard.
Yeah, exactly. So I think I was once, reading about, one of the books by David Eagleman, and the name of the book was Incognito. And he also, shared the learning curve model, that how you remember things. And he was like, okay, if you're studying for like 3 hours straight or 2 hours straight, then the learning curve is actually that parabolic, and you take decent breaks, like after 25 minutes or 30 minutes, a break of 2 minutes or 3 minutes, and then you are actually dividing that that dip into the small parabolas, and your retention is actually very much improved.
Yeah.
So yeah, I will look after looking onto these things and these phenomena, because we can't quantify things, like fully quantify things through traditional learning. And I think these studies are very important in highlighting those issues.
Yeah, I mean, I'm 77, so I'm not going to be around that much longer. And we're really looking for the next generation who's interested in this kind of theories of learning and emotions to pick it up and carry it forward. Because if that doesn't happen before I'm gone, it's probably not going to happen at all.
And actually, me and Joshua were talking about that, how emotions, how emotions play a very important role in learning. And he said that, okay, Barry has a lot of work in this field. Actually, he is an expert in this field. I said, okay, I will ask him this question, because something just triggered me about it. That, okay, your emotional state, how your emotional state is playing with you all the day, because in this age of information, when you have so much noise around you and you don't have tools to damp it, to reduce the noise, and you don't even know that while reducing that noise, what are you suppressing? Are you suppressing a very important information, or are you suppressing just a noise? So to filter those things out, we have to work through very delicate models, because delicacy is everything in this field right now.
Yeah, yeah.
So I was looking on to work which I can take on and study for next couple of years, and then come up with something which is a bit refined than what's being spelled out right now.
Well, this particular thing on emotions learning, you can get it on the ground floor because almost nobody is working on this aspect of learning theory. And so if you decide to spend some couple of years in it, you could very well be, on the ground floor of the next generation, developing this to the next level.
Yeah, because the other day I was, thinking about that. We have mathematical models for everything, almost everything. And I was watching this documentary on Google, on YouTube about AlphaGo, that AI that Google built, and he beat the top Go player in the world. And I was like, okay, it's a game which has a set number of rules. It's a finite game, obviously. But when it comes to the infinite games, when number of players are not specific, and it's keep on changing with time, the rules are changing with time. And in this age of information, when things are not so static, they are very volatile, and anything and everything can affect us. So we have to be brave enough to take on this challenge for long-term gain, rather than pushing the envelope just to the next decade, right?
Yeah.
So I thought it like, okay, right now I have a stable financial condition, so I'll put on some work in this field, because my father is a teacher, my grandpa is a teacher as well. So this is an innate thing in our family to
So you can
learn.
share. So as you pick this material up and play it back to your father and your grandfather to see whether whether they understand it and resonate with it, perhaps that will spur the development of the next level of this model, or the clarification of this model, so that it's understandable by people who
because
are in
I transpire to be an educator in future as well. Because there has to be much more efficient ways for teaching physics and chemistry or any other subject. Because one thing that actually bothered me, that you also mentioned, that the guy with having A in algebra and was not able to solve calculus. I think it's a similar problem that students in India have faced. Like, I think most of Indians are very good in mathematics, but the ones who are left behind, like, I'm not so great in so good at mathematics, but I feel that, void, that if I knew a little bit more mathematics, I could have been more clear in my expression of what I'm actually, but what my mind is actually up to.
Yeah.
So yeah, that inspired me to like how to find, very efficient models of learning, which can leverage actually whatever's being built already. We must at least apprehend that, and we must work on their applications. And it can't happen if you don't even understand the concept. And concepts are like very beautiful. Like sometimes it's a wonder that how we came across these concepts. But yeah, I think the awe of wonder, the sense of gratification in learning new things must be kept alive. And that's how we're gonna grow like 10x or 100x in next few decades. I think it's going to be really monumental thing if we could get it through.
And I would love to live long enough to see that get off the ground.
Yeah.
So you have your homework cut out for you now, Digi.
Yeah, exactly.
Not just your homework, but maybe a 2, 3, 5 year chunk of your career, possibly.
Yeah, exactly. Because one thing inspires the second, and second inspires the third.
Yeah.
And I think this thing is going to like really helpful, because I was thinking about it. I was thinking about learning these things. Then there was not so specific work done by anyone else in this field.
That's
You know.
that's true. And it's also a disappointment, because the last thing
Yeah.
you want as a developer is to have nobody can carry it forward to the
Yeah.
nation. And that's what really I'm kind of afraid that this material could just end up, in the stacks of the graduate library, which nobody ever looks at. That's the real problem.
Okay.
I mean, Archimedes had developed the basics of calculus, and it was lost. It was lost for, I think, 1,500 years. We would have had the calculus thanks to Archimedes if his work hadn't been lost. And I don't want to be like Archimedes and do work that's, that has value and then just sort of gets lost and forgotten.
Yeah, I think the device that was recovered from, I would say, from an ocean, or what was it called? The Antikythera system,
Yeah.
which was
Right.
used to calculate the cycles of moon and sun, and it could predict the eclipse.
Yep.
And it's not just about that machine, that how precise it was. It was the amount of knowledge which was backing that device.
The amount of
That
engineering
was
that went into
lost.
that is just astonishing. And
Yeah,
look how long
exactly.
it took 20th century researchers
Yeah.
to deconstruct it, to analyze
Yeah.
it.
Yeah,
Took
almost
them
like,
decades.
it took almost a century to
Yeah.
to actually understand its working and its machinery. And I was like, okay, this thing was there, like in 325 BC.
Yep.
And still, like if humanity could have picked if humanity could have to pick the cradle of knowledge from that point, we never know what we have missed, because we have lost those documents, and we have lost those civilizations.
Yeah.
We have lost that knowledge.
Yeah.
So I think today it's the golden time when things are not lost, but actually overburdened by the stacks of useless topics and useless things. So today we need a filter to get things out.
So I'm going to put my money on you to be one of the pioneers of continuing this research into the 21st century.
Yeah, I would love to do that, because it's just like it's just like, I would say, a miracle to me, because I was talking about this with Joshua a week ago, that I told him that I wanted to be in the meeting, and I was like pretty busy with settling down around here. And I asked him that, okay, we have models for to understand what happens between atoms, and all this all compiles up to a very complex machinery that's human.
Yeah.
And on top of that, we have emotions, which transpires a lot of things, that motivates a lot of actions.
Yep.
And we'll keep it out of equation whenever we are considering anything, because we don't have a method to quantify our emotions, to actually understand the spectrum, that how things could possibly change, by understanding these emotions.
Yeah.
So he said that, okay, Barry has done a lot of work on it, and you must ask him next time whenever you have a chance to talk to him. So yeah, I'm very excited about it.
So we can, Sundays we do the collaboration session instead of unlike the Saturday session. But one of the things that Sam wants to do on Sundays at the same time is to talk about collaboration. And this is one possible topic of collaboration for the Sunday sessions, is to dive into this material and review it and master it and figure out how to apply it, and how to nurture it and cultivate it so that it becomes useful to the young people of the 21st century, of which you're an example.
Exactly. So I'm very excited to take this thing on.
Excellent.
Yeah.
Okay. Anything else you want to talk about before we end today's session?
yeah, I would say thank you so much for
Perfectly welcome.
for shedding light on this topic, which was like which is very close to my heart as well. So yeah, thank you so much.
Super. You're perfect. I'm
Yeah.
thrilled, tickled to death to have somebody who's interested in it.
Yeah.
Okay, and I think with that, then if we're kind of done for the day after a couple hours, we'll go ahead and end the session. Sam is
Yeah.
driving to Canada, so he's not with us today, and Josh is gone.
Yeah.
All righty. So I don't know if I'll see you tomorrow on the same time, same channel.
Okay,
If
yeah,
not-
sure.
If not,
I'll be here. I'll be here tomorrow.
all right. Yeah, so we can, if Josh comes back, we can sort
Yeah.
of nail down the
Exactly.
learning journey for this material. Okay?
Yeah. Yeah.
Super.
All right. Take care, Barry.
Bye-bye.
Bye-bye.
Stop the recording. I can. Let me see if I can. I guess I can't stop it, even though I'm a co-host. Am I a host or a co-host? I don't seem to have the ability to stop the recording. So when I stop this, it's going to keep on running. I do not have the ability to stop the recording, and I don't have the ability to end the meeting. Oh, I do. End the meeting for all. End the meeting for all. That will stop the recording. See you tomorrow, Sam.